Good afternoon, ladies and gentlemen. I hope you enjoyed the song. It's great to see so many of you come here to the Innotribe session. Artificial intelligence in financial services obviously is of great interest to everybody. And I am not going to speak for long. I am only your moderator, but we have here today three very experienced and very knowledgeable people to lead you through their respective showcases. And these showcases will be in the three segments that Sibos has divided its program in: banking, securities, and compliance. Ladies and gentlemen, to fill us in on what's new in artificial intelligence, where the new frontier will be, we have with us today, and I will start with the lady, Lisa Wang from Betterment. Lisa is Head of Quantitative Analysis and Research at Betterment. She holds a degree in mathematics and biochemistry from UCLA and a PhD in theoretical physics from Harvard University. Need I say more? Prior to Betterment, Lisa was a quantitative strategist at Goldman Sachs, leading research collaborations and building models for fixed income strategies. Lisa is the brains behind the cloud Ferrari that is Betterment's Monte Carlo performance testing framework. So, on my right, Eric Rosenblum. Eric Rosenblum is based in Palo Alto, where he runs product management at Palantir. He works on everything from cybersecurity, anti-money laundering, and other regulatory technologies. He was formerly Director of Product Management at Google, responsible for commerce, and lived in China for 12 years, where he was also working on payment systems. He also is a graduate of Harvard University and the MIT. And then, last but certainly not least, ladies and gentlemen, from France, Edouard Darchambault, who is a data scientist in charge of data science and artificial intelligence lab for one of France's biggest banks, BNP Paribas, in the section of corporate and institutional banking. Edouard joined BNP Paribas only this year, having previously held different positions focusing on advanced technological research and operational projects in major banking institutions and hedge funds. Edouard graduated from École Polytechnique in Paris, for those who know, that commands respect, with a specialization in applied mathematics and computer science, and holds a degree in machine learning and computer vision from another of France's elite schools, ENS Cachan. Ladies and gentlemen, we will go through the three showcases, starting on my right with Eric, and then Louisa, and then Edouard. So maybe Eric, if you could start.
Wonderful. Well, thank you all for coming. Thanks for taking a few minutes to hear about AI and financial services. I want to take just a couple minutes first and talk about my company, Palantir, because people here may not be familiar with it. But I also think it's notable, we are AI skeptics. And so it's something that is a little bit unusual that I'm here. We work on AI and machine learning. It's an important part of what we do. But it's very deep in our DNA that a lot of the hard work with data happens well below the surface, how you structure the data, how you put it in a usable form. And we're always suspicious of using AI as like a fancy bauble. And I'll explain that in a moment. But first, where we came from, Palantir was founded in 2004. It was founded by the team that founded PayPal. And in 2001, when they became young multimillionaires having sold PayPal to eBay, they were struck by September 11th, 2001, the terrorist attack. And they had it in their heads that they were sure that a CIA analyst had access to lots and lots of data, but they were also sure that they had terrible analytical tools to work with. They knew nothing about the CIA, but it was a good bet. And sure enough, the bet turned out to be real, and they managed to sell a suite of analytical products to the CIA, and that became our first investor. And back in 2001, we were off and running in this world of big data analytics. Now, we had a philosophy at that time, though, that came from PayPal, which was if you try to find a needle in a haystack, if you try to make the machine solve the problem, that's a very difficult computer science problem, and in fact, burned a lot of cycles at PayPal and proved to be fruitless. They decided they just needed to burn the haystack down to a manageable size, and then let an intelligent analyst come up with the last bit. At any rate, long story short, and I'll come to this at the end, we were successful working in the terrorism business, but we learned that that general toolkit applied to many industries, which is how do you structure the data, build analytical tools on top of that to assist a human, and then allow humans to make better decisions. And so today we work in everything from oil exploration to building, manufacturing airplanes, all this, of course, on the data analytics side. We're not building anybody's airplane, don't worry. Now, we also started with 14 engineers sitting in Palo Alto, where I sit as well. And now we're 2,000 people, and we're mostly engineers. We don't have a sales team. We don't have a marketing team. You'll see that in a moment. I'm not a very polished presenter, but we're all, I'm maybe more presentable than the average engineer in terms of public speaking. So they let me out of the room every now and then. But it's an engineering-focused company. We believe in building good systems and working on the data itself. Now, my comment a moment ago that we believe the hard work takes place under the surface. And we work on product development. A lot of it has to do with how you manage data pipelines. Particularly for large companies or large government entities, they have so many legacy systems that they end up with a big choice. They either A, embark on these giant transformation projects that take years and have a high failure rate, or B, they basically work with the data they have in a highly manual way. They hire lots of people to go through the data, and they end up not being able to utilize that data set. And so what I'm going to talk about is first, the importance of getting the system right, and then we'll show some applications you can build on top of it that include machine learning and artificial intelligence in very tactical ways. But I wanted to start with a quick story that kind of illustrates our philosophy. So in 1997, an important event happened, which is Garry Kasparov lost to Deep Blue. This was big. This is the first time a grandmaster had lost to a supercomputer in chess. And it sent a shockwave through the world. And everyone was thinking, oh, it's the dawn of the machine. Artificial intelligence could take over the world. It's the first harbinger of the apocalypse. And over the next 8 years, between 1997 and 2005, you had this pendulum swing back and forth, where machines would sometimes beat humans, humans sometimes beat machines, and you go back and forth on this. But after 2005, humans have not beaten a supercomputer. It's not really possible for a grandmaster to take on a supercomputer by themselves anymore. So that debate has ended. For things that are computationally intensive, a machine will beat a human. But one of the interesting things that happened, in 2005, there was a competition called freestyle chess. And you could enter in any combination you wanted. You were able to enter with a machine. You could enter a human with a machine. You could be a computer scientist who didn't know how to play chess and just have your own chess technology with you. You could have any combination of people. You could have hundreds of people enter as one, whatever you wanted to do. And the learnings from that experience were really fascinating. So in third place was a strong machine. It was this machine called Hydra, which was more powerful than Deep Blue. It was built specifically for chess. And indeed, no human could beat Hydra. Hydra was undefeated in head-to-head competition. However, Hydra was defeated by a grandmaster using a laptop. So grandmaster, strong player, weak machine, and the grandmaster had a chess interface. So he used that to calculate possible moves and helped him computationally quite a lot, and he beat Hydra. But the really fascinating thing was the winner of the competition were a bunch of chess amateurs, computer scientists, that had built a bunch of laptop-based systems that were optimized for this competition. And so there were 6 of them together, and they built a system that was based on cheap computing, and they won the competition. And so one of the big takeaways from Kasparov's book in 2010 was that weak human plus better process was superior to a strong computer alone, and most remarkably, superior to a strong human and machine plus inferior process. And this really encapsulates Palantir's philosophy, which is it's folly at the moment for many things to try to remove the human altogether. Humans are still quite good at some things. You also have to use machine learning and these kind of advanced analytical techniques very tactically and appropriately. You need to know what problem you're solving and why is it that a human can't solve that problem. But then also assist the human with an interface that removes friction. And this is also an important thing. We think that our systems should be intuitive and beautiful. We think humans should want to use them, and they should be purpose-built. So I'll show a very brief demo that displays this. Now, the demo I'm going to show is around compliance and also revenue and profitability, and basically makes the point that if you build a good common data foundation and tactical AI, you assist people with a good AI system, that you can help a smart analyst. And again, we always say this, we're not trying to remove the analyst from this equation, solve these problems. And I could have put anything, in this case, it's compliance plus opportunity, but building applications atop this framework can become very rapid and very powerful. So flipping to the demo. One moment. Okay, so now I'm going to describe the problem that I'm going to take you through. So many of our clients are banks. And banks came to us with an issue that was well suited to this philosophy. They said, we have, for our regulators, for FinCEN, every 2 weeks we get a list of names. And those names may be as few as 12 or as many as several hundred. And we have to respond to a 314A request with a report stating what is the relationship between these individuals and our bank. And the way we currently do this is because all of our systems around the world are disconnected, our IT department pulls the data into CSV files. That then turns several hundred names into several thousand potential matches. We ship that off to India, where people manually dedupe all of these things and come up with whether or not these names are the same people or not. We ship that back to financial crimes based in New York, and they do, again, more sophisticated deduping, and they write the report. And then the whole thing happens again. They said, this is crazy. Could you help us with this? And could you build something we can build on for the future? And so what we built them is quite simple. And so first, the report comes in the form of a PDF. And the PDF can easily be parsed and loaded into the system. And what I'm going to show you again is quite basic. I was talking about Elise about the difficulty sometimes doing a live demo. Now, obviously, this is all fake data. For those of you who are Batman fans, it's a big geek culture thing, but Harley Quinzel is from the world of Batman. But essentially, you're extracting the data from this. Now, where does AI come in? Now, when you're wondering if these people are the same people or not, generally in entity resolution, most banks are using giant trees of rules that say if the last name matches within a certain degree and you have this many digits of their date of birth that match and these other, then consider it a match. If not, don't consider it a match. And so very simply, again, very simplest example, the right way to do this is probably machine learning, that you can build a training model against all of the data that you have and figure out which factors would lead to the most probable matches. So in this case, the machine has already done the heavy lifting for us. It's already gone through and given us with each person what probability they should be matched. And not only that, it will give a human analyst a view of all potential entities, what degree of confidence we have and why, and allow them to resolve or unresolve. And so the machine gets smarter over time. Now, the point I'm making here is you've gone from a system where humans had to dedupe, humans had to do all this work, but they would never get smarter because they're just dealing with individual spreadsheets, sending it back, to building a data asset where you now have a golden record of every customer at your bank. And everything I just did is only going to take about 20 seconds versus this previous workflow that took something like 200 people 2 weeks to do. But again, it's very simple. Now, finally, when the regulator comes back and wants, under subpoena, more information about some of these interesting people and says, well, what do you know about them? You're able to do everything from network analysis, which is where actually Palantir started, is the ability to link people against transactions and objects, against companies, understand related entities so you could change the investigation to go into new people, and transaction analysis. And the reason you can do this is that now you've set up a good data set. That before, this was just a set of unrelated spreadsheets. You've now resolved them using a machine learning approach into a golden record, and you can do interesting analysis. Now, all of that, again, like I said, it's not that hard. All the hard work happened below the surface. But the really interesting thing is now that we've done this, we can take precisely the same data and look at it from a revenue generating standpoint. So now we're at the same bank. And they said, now that you've built this really interesting thing for us, can we start to make money using the same database? We said, probably could. So now we're looking at it from a revenue generating standpoint. And now, because we have a golden record of each person, all of their accounts, all of their data, We can understand their profitability. So in this case, this person is worth $568 a year to this bank. We know what products they have. Relationship depth is an internal bank bucketing for how much they interact with the bank, how they interact with the bank, et cetera. But we can also see every time they've ever interacted with the bank, every call they've made, every time they come to an ATM, every time they've seen a teller. But not only that, we can also see every time the bank has communicated with them. It turns out that the investment group has sent them an email every now and then on some regular basis, but the other groups have not. Now, what can you do with this data? Well, again, in this bank, when the marketing department wanted to get people to say, get credit card services, they would have to do this custom data pull from each department. So in each country, each product group, they'd pull data, and they'd try to analyze who all the customers were. And they'd make estimates of things that, when I was at Google, are very easy in some ways. They'd have to estimate CTR, so what's the probability of people clicking on your ad? PCVR, what's the probability of conversion? What's the expected lifetime value? What should you bid? In the offline world, or the omni-channel world, these are very hard things to calculate. But now that we set up this data set, and we're able to apply basic machine learning techniques to this, which means every time someone clicks on an ad, then we increment their propensity to click on certain kinds of ads. We have basically been tracking the behavior of all these users. You can do pretty great things. So now for the marketing department, they can look at every segment, and this is looking at every customer in the bank, sorted by their products versus depth of relationship. We've done the hard work of encoding all the business rules. So we've taken the 24 million clients and take it down to the 5 million they're allowed to market to for one reason or another, because many are excluded for operational reasons or risk reasons. But we're able to allow them to drill down very quickly. Whoop. We're back. So I'll take you just through part of this in the interest of time. But basically, we allow them to now drill down to which segments they're interested in. So in this case, they're interested in millennials. So we're down to 795,000 people. They're interested in marketing to those who have other credit cards, so OFI, other credit card institutions, and this keeps on coming out for some reason. Anyway, to just talk you through it, what we're able to do is first allow them to design a campaign quickly and easily. But when the machine learning comes in, what they can then do is, without having to guess, we let the machine do the heavy lifting of predicting the click-through rates, response rates, conversion rates, and finally, what the campaign should be worth. So a marketing department that used to take 6 months to set up a campaign, they can now run this in several weeks and start getting the results tracked. Now, the thing that I want you all to take away from this is that oftentimes our clients are fascinated by the possibility of AI, or fascinated by the possibility of machine learning, and they don't necessarily think about what tactically are they trying to achieve with this. And not only that, they're obsessed with this idea that all these people, and people are not good processors, and they need to replace people. And our philosophy is always, think about what your people do right now, and which parts are they bad at, and how can you accelerate their ability to learn. But more importantly, how do you set up a data asset that gets smarter over time, and put in the hard work of building the good underlying foundation and applying AI tactically to a very specific problem. Now, again, in the interest of time, because each of us has limited time to speak, I'm going to be here after this. I'm going to be here for the rest of the day. And so I encourage you, if you're interested in this topic and how we apply this to other areas, that you come and find us. But the last word that I'll say on this is, in the end, building the application on top of a data asset, a good data asset, is fairly trivial. It just has to do with how disciplined you are in rolling out some of the data science. And I shouldn't use the word trivial, but it's not as difficult or as time-consuming as setting up the data asset to begin with. So I hope after this that we have time and we can talk more about how we do this. Thank you.
Thank you very much. Thank you very much. Fascinating to see what AI can do in compliance for you. And I think that now Louisa lead us into securities.
Do I push it? Thank you, Nicholas, for the kind introduction. I've been fortunate enough to come to a few Innotribe talks, and it's been really fascinating. So I'm especially excited to talk to you guys about Betterment. I'm going to start by saying a few things about Betterment. Some of you guys may be familiar with us, and others may not be. Um, we are an online financial advisor that's focused on providing investment management as well as goal-based advice. And we do this at a much lower cost than traditional advisors. And how do we do this at such a lower cost? And it's because we leverage technology. We use technology to do pretty much everything that we do at Betterment. We use technology to automate our investments. We use technology to automate trading. We use technology to give you automatic advice, as well as we use technology to optimize customer behavior. At Betterment, we believe in our mission, and we believe that our mission is to simplify investing and to be able to manage people's financial lives so that they can live better. And we've had the vision that we're going to be the self-driving car of financial management. And the way we're going to get there is that we're going to stick to our core value. And our core value is that we achieve efficiency through automation and iteration. Since launch, Betterment has been a leader in this industry. Betterment is the largest and fastest growing digital advisor. We launched in 2010, and so far we accumulated almost $6 billion in assets, as well as almost 200,000 customers. And I put this slide up with the big word trust, because trust is very important in any relationship between a financial advisor and the customer. Trust is what allows the customer to truly set it and forget it. But how do you build trust? You have to know the customer, and the customer has to believe that you're doing everything in their interest. And at Betterment, we build trust by using data. And we use data to make virtuous things easy and effortless. We use data to manage and understand customer behavior. And finally, we use data to customize and personalize the portfolio and our advice for the individual customer. And we're making investing better. And how do we make investing better? It's not a trade secret. It's not our secret sauce. We just make it easier. We make it simpler for the customer by making good things easy to do. Here's an example. We really believe in long-term investing, long-term goal-based investing. As human beings, when you have a goal, it's easy for you to work towards that goal. So when you come to Betterment and we consume your goals data, as well as when you would like to have that goal achieved, we can give you a portfolio, and we can give you a risk level that you should be in. On top of that, we tell you how much you should be saving in order to achieve that goal with a certain probability. And if you're in retirement and you want your money to last, we also have models and algorithms to tell you how much you should be withdrawing so that your money will last throughout your lifetime. And lastly, if your goal is to save for retirement, we have algorithms and we have aggregation of data so that we could give you personalized advice on how much you should be saving for retirement and how you should be saving. So these are all the things that we can do because we're leveraging technology and aggregation of data. I show this because this is an example of what we give you at the portfolio level. So Betterment gives you a global, diversified portfolio based on your goals. And I also show this because most of the financial industry is obsessed with portfolio optimization. I'm obsessed with portfolio construction. And we are obsessed with it too. We're constantly tweaking our models to make this better. But for us, this is a starting point. On top of this, we layer at least 3 layers of tax optimization, as well as automatic advice. And we optimize for behavior, as I will explain later. We hear so much about big data and how big data is powerful. Here, I'm going to show that a little bit of good data can be powerful too. So we have a feature called Smart Deposit, where our customers can link to their bank accounts, and we can consume their bank accounts data. And on top of that, we build an algorithm which will sweep extra cash and deposit into the bank account, and then we automatically invest it for them. This is an example of what we do by making savings easy, because saving to achieve your goal is a good thing, and it's something that you can control. So by default, with this feature, you're saving extra cash, and on average, you're saving 1,500 extra cash. So there's a pig with a bomb on it, because behavior can be a deterrent. And ultimately, we want to understand customers' behavior, we want to understand their motivation. Because if we understand a customer better, we can be the best financial advisor to them. We want to understand behavior at the aggregate level of our customers. So this is our own proprietary index of basically a pulse on how the customers are feeling. And we can run this every day. Today is pretty neutral, but you can see in the beginning of the year, there was a lot of negative sentiment. But we want to understand client action. We want to understand why did they do what they did. For example, if they made an allocation change, why did they do it? Are they trying to market time? Is it because their financial goals have changed? Well, we ask them, and a lot of the customers tell us why. And one of the more interesting actions that we care about is withdrawals. Why are customers withdrawing money? Well, it turns out from this data, we find out that, well, they need the money. That's why they're withdrawing. So it makes a lot of sense. But we also see from this data that some people are market timing. And we consider market timing bad behavior. And we want to mitigate bad behavior because it's costly to the investor. And there's an extensive literature on the behavioral gap. The behavioral gap is basically the difference between what investors get back off of a benchmark because of their behavior. And a small minority of our customer do market time. And we can see that because we can see that they're changing toward bonds when the stock is tanking, or they're changing toward stocks when the market is doing well. So we want to mitigate this behavior because we know it's bad for them. And in general, when we look at our customer data, we find out that the people who fuss more, they're worse off. This behavioral gap increases as they're changing the number of allocations to time the market. So, but not every customer is stressed out about the market. How do you identify the ones that are and the ones that are not? And this is where all the machinery of AI and machine learning can be used to identify and build a predictive model so that we can use this model to do targeted intervention, like send a targeted notification. So far, I talked about Betterment consuming data and creating data. I want to talk a little bit about giving data back. And that could be extremely powerful. A little bit of good data back at the hands of the customer is extremely useful. So this is an example of what we call tax impact preview, where if a customer is trying to initiate an action like change allocation, we'll tell them how much they're likely to incur in taxes. And in this example, somebody's trying to change from 68% allocation to 91% allocation, and we tell them that they're going to owe $1,427.68 in taxes. Now, with this information, they can decide if they still want to do the allocation change. And under the hood, we built a behavioral model for that flow of tax impact preview. And what we find is that we saw a significant reduction in realized gains because people care about taxes. As a matter of fact, as the impact tax grows, the less likely they're going to change their allocation in this example. So finally, I get to personalization. And this, I believe, is the next evolution in the digital advisor space. And we're already starting to do that. We're already using aggregation of data to build more personalized product. And one example is what we call Retire Guide. Retire Guide includes the aggregation of a lot of data as well as underlying models to tell you how you should be saving for retirement. And I'm going to show a demo right now. Sorry. It's supposed to show, oh, here we go. So we ask for personal details, like your age, your wife's age, and so forth. We ask for income, your income, then we calculate the total income for the household. We also figure out at what age you want to retire and how much you want to spend in retirement. It doesn't show it here, but we also ask where would you want to live in retirement as well as your tax situations. And then we go out and look using aggregation all your account holdings from whatever you've linked to Betterment and figure out how much you saved so far. And from that and some underlying models, we can figure out how much you should be saving. And if you can play around with that savings amount, and then we can tell you if you're going to be off track or on track for your retirement. And you can also play around with those assumptions like the economy, your portfolio, your income, and your taxes. And we also tell you how to save, where to put your money in which account. And these are all the things that we can do because we leverage technology, we leverage aggregation, and we leverage data, both internal and external. So I come to this slide, which is probably the most important slide of this talk, and it represents how we see our future. So our future, the future of Betterment is the consumption, creation, integration of data so that we can give the best holistic, integrated, and most personalized advice out there. When we're able to do that, we will become our customers' central financial relationship. Thank you.
Thank you very much, Lisa. That was very impressive. And now after these two American showcases, let's move over to France with Edouard Archambault from BNP Paribas.
Thank you. Okay, hello. So I think that if we are all here today, it's because we feel that artificial intelligence will be important for our industry, but we still don't know how much, how far. And at the same time, our world is becoming binary. I mean, there is one search engine, Google, there is one Facebook, there is one Uber, there is, one Uber, and so it's becoming binary. What it means is that today, if you have the magic formula, you can just build a giant in weeks or months. And on the opposite, giant, well-established company can just disappear in one night. On this topic, let me share with you a personal story. 2008, September the 15th, I was in London, Bank Street 25, and it was a very special day for me because it was my first day. It was my first day at Lehman, and was also the last day. I mean, the day the bank went bankrupt. An institution more than 150 years old, seen as unshakable, can disappear just in one night. So today at BNP Paribas, we see our job as making sure that we do not miss any shift, and for my part, that we do not miss any technological shift, because, it's not because you are big that you are eternal. Now, let's answer two questions. The first one is, why do we do artificial intelligence at BNP Paribas? And the second one is, how do we do it? Okay, why? I want to share with you 4 reasons. The first one is obviously because our clients need it. Our clients, are like you, like me, they're already used to it, used to smart products, services, personalized, able to anticipate their needs, Google products, Apple products, and they are expecting exactly the same from banks. So this is the first reason. The second one is that we are in an exponential world, and we have to be prepared for that. Ray Kurzweil, chief engineer at Google, says in less than 15 years, we may be able to replicate the human brain on a computer. Artificial intelligence revolution may be the biggest technological shift ever, bigger than the computer revolution, the internet revolution, or the smartphone revolution. And our world is exponential. What it means is that in our century, the 21st century, we are not going to have 100 years of technological progress, but 20,000 years at today's rate because of this exponentiality. And we have to be prepared for that. So this is the second reason. The third one is that our business is shifting. We are in an information world. And our business is shifting from managing the financial transactions of our clients to processing their information to provide them with intelligence. And same already happened in other industries, for instance, automotive. It used to be a business of engines, motors. Google came, invented the self-driving car, the Google car, and turned it into a business of information processing. And we are expecting the same for our business. And the last reason is that we think that artificial intelligence is our DNA and that we have everything to do it. What I mean is that our business in banks has always been to invest in intelligence technology to provide our clients with best advices and services. In CIB, in corporate and institutional banking especially, where we deal with complex organizations, meaning a lot of data points, high dimension, artificial intelligence is particularly well suited. And we have everything to do it. We have the brain power with quants, we have the computing power, today cheap and available, and we have the data. And data is something that, for instance, FinTechs do not have, I mean, at least on our clients. And we are leveraging on it. And the best proof is that we are partnering with leading research academies because they are interested to work on our data. So this was the why. Now, how do we do it? To introduce you the how, let me share with you a short video.
The use of artificial intelligence is growing exponentially every year, and we have witnessed its spread in every domain of the economy. Artificial intelligence is bound to disrupt the banking model as we know it today. And on top of this, we are facing new entrants and new competition from tech giants who are entering in the banking space. Artificial intelligence is for us a way to improve speed, quality, relevance, and added value of the solutions we deliver to clients. It's also a way to develop new business models beyond traditional financial services. And last, it drastically increases our organizational efficiency as well as our employee engagement. To give you two examples, we are developing data-enabled models that analyze, anticipate, and predict our client needs. And we expect to develop Siri-like assistants to serve as digital voice advisors to enhance our clients' experience.
The online version of the report is a fantastic tool for our front officers, not only for our clients. Prior to a client meeting, they can drill down the data, they can filter it according to the industry, according to the size of the company, the geography, or what have you. And this then allows them, the sales guy or the coverage team, to present their clients with a set of benchmarks on how their peers actually manage their treasury, how they are organized, what type of products they favor, what types of priorities are important for them.
At BNP Paribas, we have started automating some processes using natural language generation tools. NLG is the major evolution of artificial intelligence. Machines are now able to apply expert knowledge on data, to write explanations and syntheses in plain language. Let's see how NLG works. We can automatically produce a tennis match report in natural language, knowing the facts and the final results. NLG goes one step further. It can produce on demand different versions of that report by modifying input data. Let's say we have selected 3 parameters as inputs. By changing these parameters, we see that the report is dynamically changing. NLG applications can process a huge variety of plain text professional reports in the interactive manner, allowing people to reach a great level of personalization with high-quality results. We see multiple applications of NLG technology in banking to produce reports using the source data on which machines apply expert rules to deliver conclusions in plain language. My Contact is our internal social networking platform for bankers. We are using multiple data sources, both internal and external, in order to find client contact information. With fuzzy matching algorithms, we are able to clean and prepare the data. Then we use graph databases to build relationships between those contacts, identify network connections, and develop an interactive representation of who knows who. In addition, as a first step towards having a digital voice advisory, we have developed a conversational assistant to simplify app interaction with end users. A banker can ask questions about their contacts through natural language and get answers right away.
So about the how, we asked ourselves, how did the most disruptive innovation happen? I mean, PageRank from Google, Macintosh from Apple, Windows from Microsoft. How? It all started in a garage. So at BNP Paribas, what we decided is to go back to the garage days, meaning to find this entrepreneurship spirit. What I mean by that is no more useless, endless meetings, no more red tapes. So to focus on one objective. And with what team? With a team of smart, digital, skillful, complementary profiles. So today what we have is our own facilities, organized to facilitate communication. We have no hierarchy, low report line, and no slides. And the team, even if small, is made of data scientists, data architects, ITs, web developers, web designers, PhDs. And it's a huge revolution for a big institution like BNP Paribas. And I think it's part of our success. And in this team, we all have something in common, is that we think that data is not gold, but it's a diamond. Data is a diamond because it's the most valuable asset when you want to do AI, with brain power and with computing power. Because it's a diamond because its value comes from its structure. And this is the reason why we spend so much time just structuring information, using text mining, graph mining, and even deep learning. And data is also a diamond, because as a diamond, it has multiple facets. for instance, a contact data, a data on a physical person. It's a biography. It's a list of contacts, and it's a news feed. And when companies say they want to have a single view of their client, in fact, what they want to have is a multi-dimensional view of them. They want to have this multi-dimensional view so that every stakeholder can view the client from the perspective it matters to him. From the CRM perspective, from the client perspective, from the risk perspective. And this is the reason why what we do is that we take the structured data and we map it into knowledge bases or graph databases so we can have this multi-dimensionality. Now let me illustrate with a concrete example. My contact. You saw it on the video. Our contacts, our client contacts, were a list of bad quality data in the CRM. So we took it, we cleansed it, we deduplicated it, we enriched it with external data, we structured it, and we mapped it into a knowledge base, building a social network of who knows who, where nodes are people, and edges are relationships. And what we did then is we put a knowledge-based artificial intelligence on top of it with a conversational assistant so that every user can use it just like you can use Siri, just chatting with data with the system. And this work was done in 3 months, only leveraging on free open source tools, Python, JavaScript, MongoDB, TitanDB. And because we are in a collaborative economy, we also intend to make part of this technology open source. Now, to conclude, let me say that, artificial intelligence is a huge revolution. But I was saying in the introduction, we still don't know how much, how far. But what we know for sure is that artificial intelligence is a Darwinian process, meaning that it reinforces the selection among players. And this is the reason why we think it's very important to get prepared so that we are selected by our clients. Thank you.
Thank you. Thank you very much, Edouard. Well, ladies and gentlemen, after these 3 very impressive and fascinating showcases, we only have a very, very short period of time left for what we wanted to do in terms of discussion. And I'm sure all of you have multiple questions. Unfortunately, we will not be able to go into Q&A. I have also a series of questions, very minor questions, such as what will be the place of the human, when will machines replace humans, and so on. But maybe let's just pick the brains of these 3 fantastic presenters on one question, and that is, where is the limit of artificial intelligence? I don't know who wants to start on this. Very briefly, your take on where would you see the limit of artificial intelligence? Eric, you had most time to relax.
Yeah, this is very relaxing. I don't really think there is a limit. I think that you have this exponential, you have at least 3 exponential trends. You have exponential availability of data, exponential increase in computing power, and exponential development of techniques to start to mine and make sense of the data. So all 3 are developing very quickly at an increasing rate. I don't know if there is really a limit. To us, the big inflection point is one of the questions you alluded to. At what point does it clearly pass the human? So the example that I gave, where even now, a supercomputer will not beat a grandmaster with a simple chess program. When will that no longer be the case? And humans simply can't compete at all. And when has it gone from pure computation to actual innovation and thought? And that's a more interesting question to me, but related. And there, it's what Edouard brought up, which is the rate of increase is so fast. It's very hard for us to predict this. In 20 years, we're going to move faster than we had in the last 1,000. And so it's very difficult for humans to even think in exponential terms.
Okay. Well, thank you very much. This sounds a little bit more pessimistic than what you said in your presentation when you very generously underlined that humans are still quite good at some things. Maybe I hadn't really understood the cynicism in that sentence. But anyway,
and
Lisa,
Optimus
do you
still
have...
thinks humans have 20 years left.
I actually think that AI does have a lot of limits. And the limit is that AI is not human. So what makes us human is that we have ideas and we have intuition. How does AI get intuition? How does AI learn intuition? What are the things that are not mappable to zeros and ones? And I think those are the limits of AI. Of course, an AI machine can beat a human in any complicated task. But what if there's dynamics involved? What if there's complexity? What if there's chaos? How can an AI machine adapt better than the human? So I think those are the limits of AI. And they may be solved in 20 years, as Eric has suggested.
Edouard, where do you situate yourself in this debate?
Yeah. So today there are many limits, and we use artificial intelligence to automate repetitive tasks. But when it comes to creativity, expertise, human is far better. Nevertheless, today people are very optimistic about AI because we have everything to do it. We have the data. Thanks to digitalization, almost all the information of the world is stored digitally, meaning readable by computers. We have the brain power, and it may also have disruption in this field with quantum computer, for instance. And I mean, we have the brain power, meaning that we understand how our brain works, I mean, far better every day. But at the same time, I agree with Lisa, because we are a little bit in the same position, at the end of the 19th century, about physics, when people, before the quantum physics, when everybody was saying, okay, if you know the position and the speed of every atom, you can just predict the world. And then the quantum physics came and put some limits. So I think that at the end of the day, artificial intelligence is going to help us to understand better our brain. I mean, what is intelligence?
Good. Thank you very much. Well.